This is problem number 3 from section 9.7. In this problem it says find determinant A by expanding about the first column, state whether A inverse exists. So we have a 3 by 3 matrice this time, and 3 by 3 matrices are a little more complicated than 2 by 2 matrices. Now they say expand about the first column. There are multiple ways to go to find the determinant of a 3 by 3. I have a formula that works pretty well for finding the determinant of a 3 by 3. So I think that's what we're going to stick with, and that's what we're going to use. So essentially what we're doing here is we are going through and finding the determinants of some 2 by 2 matrices and multiplying them by the basically the first row elements. So when we go through and find this determinant, we're going to start with A, and A blocks out the first column and the first row, leaving you just with E, F, H, I. And if you see that here, I'm going to use some markers to kind of cover this up. When we use A, it leaves you with E, F, H, I. So that's why it's A times the determinant of E, F, H, I, because A takes up the first row in the first column, so what's left is a 2 by 2 matrix that you multiply by. Same thing when we use B. B takes up the first row, and what's left in the second column, what's left is D, F, G, I. So we find that determinant. And finally, we look at C, and we multiply by the determinant that's left when we block out the first row in the third column. Now you'll notice that it goes plus, minus, plus. This is the pattern that occurs with matrices. The first row is like plus, minus, plus, then negative, plus, negative, and then plus, minus, plus, and it just repeats back and forth. So you don't really need to worry about that too much. Just realize that we're going to go positive, negative, positive. And all the negative really means is, we're going to plug in whatever number we have for B, and it's either going to change the negative to a positive or change a positive to a negative. So it's not that big an issue. So let's start and let's actually find this determinant. So we start by saying the determinant of A equals negative 3 times the determinant of negative 3, negative 4, 10, 6. And then minus 8 times the determinant of, when we block out, and we're going to do this here real quick, we'll block out this row and this column. We get 0, negative 4, 0, 6. So let's go ahead and write that. 0, negative 4, 0, 6. And then plus negative 1 times its determinant. Let's slide over just a little bit. Determinant of, so we block out these two rows and we're left with 0, negative 3, 0, 10. All right, now we have it set up. We can get rid of this because once we have it set up, we just need to evaluate now. We'll bring back our determinant of a 2 by 2 real quick. So to get the determinant of this, we're going to end up with equals negative 3 times, so we'll just put this in parentheses, negative 3 times 6 minus, and I'm going to kind of use a bracket there so I can put parentheses around this, minus 10 times negative 4 minus 8 times 0 times 6 minus 0 times negative 4. Put those in parentheses. And then this will be minus 1 times its determinant, which is 0 times 10. So we're going to write 0 times 10. And then minus 0 times negative 3. And I'm running out of room, so 0 times negative 3 no is 0, so I'm just going to put 0 in there just because I'm running out of room. All right, let's go through and evaluate this. So we end up with negative 3 times 6 in here, so we end up with negative 3. Negative 3 times 6 is negative 18. This is negative 40, but this is also a subtraction, that's plus 40. Minus 8. This is 0 and this is 0, so I end up 8 times 0. And this is 0 and this is 0, so I end up with minus 1 times 0. So now I end up with negative 18 plus 40 is 22. So negative 3 times 22, which is negative 66. So our determinant for this 3 by 3 is negative 66. And what does that mean? A inverse does exist. So we can say A inverse exists, which is the whole point. It's not 0, so that means it exists.